Hello everybody. So this is the beginning of our exponents or our exponential and our logarithmic function unit. So in the previous unit we looked at polynomial functions. So we looked at graphs that had x and x squared and x cubed. These ones have a different form where instead of the exponent being a number like 2, 3, or 4, now my exponent is my variable. So in this case, my exponential function has the form a times b to the power of x. So again, x is no longer my main sort of variable. Now x is my exponent. And there are, exponential functions, they have either one of two shapes. So the first one starts down low and it increases as we move further to the right, or we start high and we get lower and lower as we go along. But if you look at these two graphs, they never cross the x-axis. They never cross the x-axis. Now we could add some extra numbers to this exponential form, but we don't have to worry about in this course. That's more of a grade 12 pre-calc topic, so we don't have to worry about that in applied. Okay, so again, my graphs, they start close to 0. They hit a point somewhere here on the y-axis, and then they just kind of take off from there, or vice versa. So like I said, there are one of two different kinds of exponential functions. They are either going to be increasing or decreasing. So in these two graphs here, this first one is called an increasing graph. And the one here on the right is decreasing because it's going lower and lower. It's going closer and closer to 0. So we're just going to go through some characteristics of these graphs. And I'm just going to flip over to Desmos first, because one thing that we're going to look at is how the value of b changes the shape of the graph. So I'm going to click over here. I've already got Desmos loaded up with the form of the equation here. I also added a slider here for my a and b values. We don't really have to worry about a, but I'm just going to keep it in here just so that we can see the shape. So you can see when a and b are both equal to 1, we just get a straight line. If I start increasing the size of b, you can see that my graph starts taking that increasing form. And the more that I increase the value, the steeper the curve actually gets. Now, if I go below 1, let's see if I can, nope, I can't click over, so I gotta just slide here using my mouse. So now that my b values are below 1, you can see that I start getting that decreasing form. But now that I've hit 0, all of a sudden my line, it like flatlines. And that's because 0 to the power of anything is going to be 0. So that's why my y values, all of a sudden they become 0. And if my b value goes negative, we start getting these points that appear. Now, the good thing is we don't have to worry about these points. In this unit, my b value is always going to be positive. So the thing that you have to keep in mind is my b value a fraction, so something between 0 and 1, or is my b value a value that is greater than 1? That is what affects the shape of my graph. Okay, so we're going to go ahead and fill in this table. So we have two different b values to consider. It's either going to be greater than 1, or it's going to be a number that is less than 1, but still positive. So when my b value is greater than 1, we had an increasing graph. And that looks something like this. So again, we get really close to 0, as close as we can. As soon as we hit the y-axis, that's when we start taking off. And because we are drawing graphs, we're going to put arrows at the end of our graphs. For the other one, when b is between 0 and 1, that is a decreasing graph, and it has the form that we can see at the top here. So we start pretty high, we hit the y-axis, and then we level out. But again, we never cross the x-axis. We get close to it, we get infinitely close to it, but we never actually cross that graph. So now if we look at both of these graphs, how many x-intercepts do they have? Do they ever cross the x-axis? And I've been trying to emphasize this throughout the previous 5 minutes of this video. It never crosses that x-axis. So these graphs do not have an x-intercept. But they do still have a y-intercept because they do cross the y-axis. They only cross it one time, so there is only one y-intercept for each of them. The end behaviors, so they're basically both of my graphs, whether it's increasing or decreasing, they both start in quadrant 2 and they both finish in quadrant 1. So they go from quadrant 2 to quadrant 1, quadrant 2 to quadrant 1. For the domain, for the possible x values, well, it keeps going to the left forever and it keeps going to the right forever, no matter which graph I'm looking at. So the domain for both of them is negative infinity to infinity, negative infinity to infinity. And for the range, well, because it never crosses the x-axis, it gets very, very close to 0, but it never actually becomes 0. So we start at 0, and it keeps increasing, going up, so the range is going to be from 0 to infinity. But we are going to use curved brackets for the 0 because, again, my graph never actually hits 0. It comes very, very close, but it never actually crosses it. So because it can never actually equal 0, that's why we put curved brackets here. So the characteristics for exponential functions are basically the same. The only thing that's different is whatever the b value is going to change the way that my graph actually looks. So we're going to take a look at a couple of examples here. We are going to make a table of values for this function. We are going to graph the function here, and we're going to find all of the same characteristics that we found in our polynomials unit as well. So I'm going to show you here in the table of values how to find some of the corresponding y values, but I'd say it's a lot quicker to actually use Desmos to find these answers. And we don't really make tables of values. Maybe on the test there'll be something like that. But on the provincial exam, usually they give you the table of values to actually put into the onto Desmos to find the regression equation. But I'm still going to show you here. So I'm going to start here with my positive values, and then we'll talk about the negative ones after. So if I plug 0 in for x into this equation, I get 2 times 5 to the power of 0. Now this is going back to grade 9. We talked about how do we calculate powers, and we also talked about order of operations. So we need to calculate the exponent part first. So 5 to the power of 0 is 1, so this is 2 times 1, which is 2. So when x equals 0, I have a y value of 2. If I plug 1 into this equation, I have 2 times 5 to the power of 1. 5 to the power of 1 is 5. 2 times 5 is 10. If I plug 2 in here, I have 2 times 5 to the power of 2, which is 2 times 25, which is 50. And we can do the same thing for 3. 5 to the power of 3 is 125, times 2 is 250. When we get into negative x's, so when we have a negative exponent, that makes my power that we are trying to solve into a fraction. So 2 times 5 to the power of negative 1 is the same thing as 2 times 1 over 5, which is 2 over 5. If I do 5 to the power of negative 2, that's 1 over 5 to the power of 2. 5 to the power of 2 is 25. So 5 to the power of negative 2 is 1 over 25. So this is 2 over 25. And if we do for negative 3, 5 to the power of negative 3 is 125, or 1 over 125, times 2 is 2 over 125. So this is why my values get much closer to 0. Like you can see 2 over 5, that's already 0.4. 2 over 25 and 2 over 125, those are already going into the hundredths or the thousandths in terms of my decimal places, but we never get an answer of 0. So what we get when we graph this out is we know that 0, 2, so when x is equal to 0, I have a value of 2. We could try to plot some of these other points. So at -1, it's at 2.5, so it's going to be below here. It's going to be somewhere right here. If I take x equals +1, that's going to be 10, which is already all the way up here. So when I draw this graph, again, we're starting very, very low. We're kind of hitting these points. We're going to hit my y-intercept and just kind of take off in going upwards. Okay, so this would be the general shape of the graph. Now, again, when we talked about these characteristics, we said no matter what the b value is, these characteristics are going to be the same. The only thing that changes with an exponential function is its shape, depending on what the b value is. So we have no x-intercepts. We have a y-intercept at 2. We're starting in quadrant 2 and we're going to quadrant 1. So Q2 to Q1. My domain is -infinity to infinity, and my range is 0 to infinity. So none of that information changes. Okay, try the next example on your own, and if you are unsure, then we will do it together, but hit pause on the video and see if you can try example number 2 on your own. All right, so I filled in the table of values here, and I also did a couple of example calculations. So for example, if I plug in 0 into this equation, I get 8 times 1/4 to the power of 0. Again, anything to the power of 0 is equal to 1, so 8 times 1 is 8. So that's going to be my y-intercept at 8. I also did this calculation here for x equals 3, so 8 times 1/4 to the power of 3, which is equal to 8 times 1/64, because 4 to the power of 3 is 64. And that's just 8/64, which simplifies to 1/8. So at x equals 3, the value is 1/8. When it comes to the characteristics, again, the characteristics don't change no matter what. So no x-intercepts. I do have a y-intercept at 8. Also, if you haven't noticed, the y-intercept is always the a value in the equation, because whenever we plug in 0 for the exponent part, that's going to make it equal to 1. So that's why 1 times whatever the a value is just a. So that's why my y-intercept is the same thing as the a value. End behavior, again, we're starting on the left in quadrant 2 and heading to quadrant 1. My domain is any possible number, so -infinity to infinity, and my range goes from 0 to infinity. So the only thing that's left is to draw the graph here. So let's just call this point 8. I'm not going to get very technical with this graph because, I mean, you can see by the values here, there's no way that we can draw it on here. But we can put the y-intercept and just show the general shape. Now in this equation, my b value is a fraction between 0 and 1, so it's going to be a decreasing function. And we can see that because for my negative x values, my y values are very high. For my positive x values, my y values are very low. So it's going to be a decreasing function that's going to look something like this. So the main takeaways from this is, again, just focus on the characteristics. Try some of the practice questions to see if you can figure out what the characteristics are, what the change in the b value does. But in the next lesson, we're going to get into the whole idea of regression again, just like we did with the polynomial functions. And we're going to interpret some data tables, draw some graphs, and interpret the information in those graphs.